Hi, everybody, and welcome back to the Renewables Podcast. Today, we are going to talk about all things fire safety, what we should and shouldn't be doing with solar PV and lots of other areas in fire safety. But before we introduce our guest, how are you doing, Mark?
I'm doing good, mate. I'm glad all my solar panels are still on the roofs of the UK after Storm Darrow, or whatever it's called. It's my first time with a big storm. And you know this stuff's rated for way beyond what that's throwing at it. But
Yeah.
I've got to be honest, I was checking those systems as the winds died away to see if they were still producing.
Yeah, I saw Corey on Instagram mentioning all about that, and that's been my life for a few years now. Where you're looking at the weather, you think, oh my, sort of refreshing the emails, thinking, please don't let there be any emails coming in. But yeah, touch wood, we've not had any of that, which is good. But it looks like we're on the back end of that storm now, which is great. But without further ado, we've got Luke Gonzales.
Yep.
And do you want to kind of introduce what your job role is
Sure.
and what sort of area you operate in?
Yeah, no, I'm Luke Gonzales. I am consultant director of CGM Group UK, specialising in renewable fire safety, including PV and battery storage.
Very good, very good. So you'll be very busy at the minute with all these installations going on.
There's a lot going on. Obviously, this year's been quite a pivotal year because there was the Peterborough fire in Lidl as well, so that was quite a big hit in the media. So that's sort of drawn a lot of attention to sort of fires related to renewables.
And so I quite like, because this is an area of renewables that we've not really ever spoken about. We speak to people that are fitting batteries, that's fitting solar, like what we are as installers in our main businesses, but we haven't spoken to anyone that is kind of out there having to assess when potentially things go wrong, but also maybe looking at if buildings have been set up correctly. So in a bit more detail, what does your job role actually entail? Like, do you get called in when there's been a problem, or do you do assessments kind of as things have been installed?
Kind of a wide range, really, because I'm technical as well, and obviously I hold electrical qualifications. I've got the BPEC, etc., for the solar installation. I get involved from early conception of a project through to completion, and some of it is technical due diligence, working for the client.
Okay.
So I can go through the specification of what the installers propose, go through it, check that they're complying with what they say they're going to do from an installation. So almost acting as an independent clerk of works as well for the client, right the way through then to sort of witnessing, commissioning, etc. as an independent, but offering installers a peace of mind that they know what they're walking into, let's say, as well. So I work for both sides of the fence, the client or the installer. And some of it is quite large stuff, like one megawatt sort of PV arrays and battery storage. And what I'm finding now is that battery storage, 1 megawatt hour and greater, are actually getting more closer to residential buildings, mainly because there's sort of microgrids, smart grids, and all this sort of advancing technology that it's sort of bringing a greater risk. So they want more technical due diligence and safety, really, because there's a lot of grey areas in the industry that doesn't really nail this as black and white, I suppose.
We're going to interrupt today's show to talk about a new product from Proteus, the sponsors of our lovely little home here on the Renewables Podcast. And this is a Type B RCBO in single module format. And this is a super exciting development, I think, in the world of switchgear for us as installers. This is 10 kA rated and bi-directional with all the right markings and logos on. I'm going to pass this over to my co-host Sam for him to have a look at. See what you make of that, mate.
Yeah, it's. I actually dug out in the unit where it's just next door to where we sat now, an older Proteus RCBO. This is a Type A, and it's a 6 kA one, and the difference in the size is next to nothing. So this is the older one here, and this is the new one. So it's basically the same size, but this is a Type B, and we know there's a lot more that goes into a Type B RCBO than does a Type AC. So it just shows the progression there that Proteus are on, and trying to save us space in these DBs by literally having next to no height difference on the two products.
I know, I mean, the Type B normally would be a couple of modules wide at least, probably more, and they've got it all into one single space is incredible. And I know from speaking with a contractor over on DMs who'd had his MCS assessment recently, was saying that the assessor had said he should have a Type B RCBO feeding into his battery storage system, which is outdoors, which is interesting. So I think we're going to see the growth in application of these things, and it's just nice to see the range of stuff Proteus have got out there for us as installers. And there'll be a link in the description alongside wherever you're watching or listening to this to go off and check that out. Let's jump back to the chat. Yeah, and we can get to that in a later chat in the podcast. But do you do some investigations when there have been incidents as well? Are you one of the people who go out and determine what fundamentally went wrong, or are you
Not yet. I haven't done anything like that yet. I tend with sort of these incidents, they tend to get dealt with by obviously local fire brigade and things like that, which have their own internal investigation procedures. But I've done, not something I've done yet, but not to say that won't come in due course, really.
Yeah, I'm on a much smaller scale in domestic settings. I do a little bit of that, not to do with solar PV, but when there's been a fire that's usually down to an appliance, helping the fire brigade determine that is what it is. And it's really interesting, the data and stats that the fire brigade keep and do. I think they do a really good job of that beyond what the insurers maybe do and us as industry. So there's a lot of data there, I think, for us to delve into. And it'd be interesting in maybe 5 years how solar and batteries play a part in those statistics. I think we look at it, Sam, as installers, where we're trying to detect prevent them firstly, but detect them if something has gone wrong with smoke detection, and we've seen it in the PAS around batteries, so people can kind of get out. But it's designing these things, especially in roof, it seems, and I'll be honest, I've not done an in-roof system yet, primarily to do with some of the fears around these kind of things, but installing things in the right way, so if something does go wrong, you've still got that fire barrier that you need.
Yeah, well, that's what I'm interested in with this podcast, with an expert in that field, to kind of air some of these myths or air some of these things that are not kind of quite clear out there, because there is a lot of kind of information coming from industry, but also from manufacturers, from wholesalers, from other installers, and it's kind of quite muddy in that case. And I think often it's good to take it right back to basics and go, right, well, forget all of that stuff that people are told. What are the actual baseline rules around this? And then we can work up from that rather than trying to work down from everything you've been told. But one thought around maybe not having done a lot of work around kind of assessing why a problem has happened. I wonder if that's because we haven't had the volume of things happen potentially yet. Like electrical fires have been happening for a long time. There's obviously, I'm sure there has been fires caused from PV. I've seen it online. I've seen some stuff that you've posted, but I wonder if it's just going to take a bit more time for, unfortunately, more of these things to happen potentially, for certainly the battery side of things, which is kind of a fairly new phenomenon when you relate it to solar PV. Solar PV has been around for quite a while now with the feed-in tariff and everything, but people weren't really fitting batteries back then because it was all lead acid and they were very expensive, took a bit of maintenance and took a lot of space and everything, whereas we're kind of entering that world now of bringing batteries inside or outside of properties. PAS has had a go at trying to regulate some of that. We've seen the stink that's kicked up in the industry. And we've said before on this podcast, or I've heard, that I'm a very big supporter in that. It's not perfect, but I am a big supporter in that. But I feel like that started on a path to actually considering fire safety and trying to bring properties up to standard now. Whilst you're spending a lot of money on a solar and PV, solar PV battery system.
Fire proofing of my base understanding is that kind of your fire barrier is your tiles on your roof, to a want of a better explanation. And there's distances between those where fire can propagate more easily than not in some of the studies that I've read over the last couple of years. And it's understanding that as electricians. It's like, where does your knowledge base need to start and end with all of this? Because there is such a lot. And, we're relying on manufacturers and people like yourself as well, who to try and guide us a little bit with information, I think. And maybe MCS needs to play a bigger role in that too. Because we don't want to install systems that are going to lead to a fire in somebody's home. We want those fire barriers, for want of a better explanation, again, to hold if the worst does happen. You can install a system with all the skill in the world and do it perfectly, but you can't account for a rock hitting a panel and suddenly causing it to ignite. Where's the testing and amongst all of that? I don't know if this is kind of what you're involved with, Luke.
I think that's a great time to bring you back in, Luke, on this. Is what are you most concerned about, or where should an installer start when they're looking at fire safety with kind of in-roof and potentially on-roof panels? Is there anything that we need to be looking at there?
I think, from my opinion, I think you've got to understand your client, the building you're operating in. And this goes back to our conversation earlier, Matt, where I was saying about knowing like the evacuation strategy, and if you're working in commercial, and the integrity of what the fire risk assessment for that building is going to be. I appreciate in domestic, you don't have that. It'll be a simultaneous evacuation, but being mindful that obviously different buildings employ different strategies for obviously in the event of a fire. And then sort of designing that out then and saying, well, okay, we're going to go for an on-roof system, an in-roof system. If you look at care homes, for example, they hold vulnerable people. So they don't simultaneously evacuate. They progressive horizontal. They move to an area which is safe. They lock it down with high compartmentation levels. So with that in mind, if you're going in roof, and potentially you're going to be breaching across multiple compartments, then that fire spread internally potentially could cross all compartments quite rapidly and jeopardize them sort of places of relative safety that they move them people to. So it's knowing what you're working with to start with, and then sort of looking at the minimum requirements, and bearing in mind, obviously, approved document B and building regulations are the minimum requirements to building regulation compliance. So it's working on that then, and obviously then referring to manufacturer's guidance and approvals, and selecting the right equipment for the right job ultimately.
Yeah, well, it's a really great example, and because we have just done a care home with an in-roof system, and they were all over me about it's like I forget what it's like, B level, T4 or something that level. And so they were all over me, and I confirmed it about 5 times because they were really worried about the in-roof panels not being the right level of fire safety to get it all signed off, really. And they also provided us with maximum distances from the fire barrier for the next compartment, where the edge of the panels had to be so far. It's like 1.5 meters or something, I think. I can't remember without looking back at the emails, but they provided us with a lot of that information. But for anybody that doesn't get that information, or that isn't maybe aware of that, we're worried with in-roof solar because we're potentially, how is that going to aid the spread of fire across? Is it more the panels combusting through a problem with the panels and that dropping into another or in between 2 compartments? Or are we worried more about a fire starting in compartment A, going up into the roof space, and then going over the fire barrier into compartment B? What's the problem?
Both options there really
Right.
are on the table, because either or could happen in the event of a primary or secondary fire, whether relative to the PV specifically or external to the PV. Yeah, obviously if it tracks into the roof space and there's not a fire break or fire stop between the compartment, and PV modules bridge over that compartment. PV modules are known combustibles mildly, not they're not hugely combustible, but they can propagate, they can self sustain. So yeah, both options are on the table there really. But I think ultimately, this in-roof situation comes down to the testing, and there's 13501 part 5 is the sort of British European standard for roofing as an external fire spread, but that only looks at the external sources of flame. So that is sort of putting a burner on a roof, for example, whether that's a tile slate roof or a PV module if integrated, and it only looks at the external. Personally, I don't think that this standard is fit for purpose for in-roof, because the ignition sources around PV, around sort of MC4s, connections, etc., which are actually within the roofing membrane behind that. So, my professional opinion is that standard for the B-Roof T4 compliance isn't a fit for purpose compliant test standard for building integrated photovoltaic ultimately.
Yeah, because you're not going to have many times, I wouldn't have thought, unless you've got a fire on another building and something's dropping onto those panels, that the fire is going to actually attack that building from above, really. I can't think of many situations where that would happen. It's going to be a fire in the building, not to do with anything to do with the solar, or like you say, an MC4 failing, or something happening, but that's all going to be underneath the panel, isn't it? So I wonder if that's a bit of a re-education for now that we're progressing a lot more with these solar PV installations, and a lot more new buildings like this care home that I was working on are now going, we need to fit solar because it's going to be part of the planning, or it's part of the EPC to get it up to a certain level.
Of course.
All this sort of stuff. Maybe now that it's becoming more common, again, it's that age-old thing of the regulations now need to also be, keeping up to speed with all of that. So yeah, it'll be interesting to see how that all progresses. But yeah, it's a tricky one.
It is, and even in a domestic dwelling, we had a fire investigation that was to do with an extractor fan. So it was a bungalow, and an extractor fan had burnt out and caused a fire in this bathroom, and it spread into the loft. But they had in-roof solar as well, and all of that had burnt away pretty much by the time the fire had finished. And they wasn't really looking at if that, built on the spread of the fire in that bungalow. Was that part of it spreading so quickly as it did, or was it just a consequence of the fire anyway? So if that tiled surface had still been there, would it have been so destructive? And I guess it's a difficult one for anyone to really prove one way or another without setting fire to a lot of buildings and doing experiments. So that's the real concern for me as an installer. I think when we're looking at some of these in-roof systems, I, speaking again personally, want a product that has been designed and built by the manufacturer for that purpose. Much like a consumer unit with all the manufacturer's switchgear in it, tested as an enclosure, as one, to fulfill that requirement. If we're kind of blending something that goes onto the roof, a plastic tray or whatever, putting a different panel on it, maybe a different optimizer, you then become responsible, I believe, for that system as the installer. You've designed it, you've made that, and you can use guidance from manufacturers on compatibility of those components to argue your case in that design. But still, ultimately, I think that falls more on your shoulders than using something that is bespoke for that job, tested for that application. So speaking again personally, if we were looking at doing in-roof, that's what would drive my design decisions. I don't know if that's right or wrong or what you do as well, Sam. But
Yeah, I mean, I've been very worried about this in terms of what we do, because ultimately, like you say, the book falls with us. We could fit a system that you would be happy to fit, Matt. We could fit it two different ways. Mine might be non-compliant. Yours might be compliant. I might have not known anything about the fire barriers. I should, or the fire breaks, and I've maybe bridged it, whereas you knew full well about them, so you've created a gap between them, and you split your array up over two different sections so that it didn't bridge that fire break. The product is the same, but the way that it's been installed has basically gone against what the building wanted or what the manufacturer wanted. And you mentioned about these other products. I think you could use any combination of products, but I think the thing is that you need a piece of paper to show that testing has been in place. And we're not on the podcast to name any products, but for any products that do mix and match, you need to, as an installer, make sure you've got that piece of paper to go, right, I'm fitting this panel with this. Has that been tested? And I think that's just raising an awareness that needs to happen, rather than just going, this pod will fit that size panel. I've now got 10 panels I can choose from, which is the highest wattage, which is the all black one. Part of your decision needs to be which one has been tested with this pod from whatever manufacturer it is. It needs to be tested. But is that your kind of take on this as well?
Yeah, I think it's a bit of a flaw as well. Just going back to, obviously, you said about the care home, and obviously they was that a consultant that said obviously put brakes in according.
I think it had come from the consultant, and they'd made sure that the builders, well, obviously the solar was planned from the start, so they'd basically said, look, you need to make sure it's this spacing from that edge.
So I think that's part of the issue, is that obviously with the proof document B around fire safety, like there's if the roof material is B roof T4, you can actually bridge over compartments. There's nothing stopping that. So, but obviously for a roofing material, that's fine. You can have fire stop and intermittent ceiling at roof level, at tile level.
Right.
But when you go into underside of modules, you're limiting ventilation, you're creating hot spots potentially, and even manufacturers who are approved for B roof T4 in roof, they advise against not bridging over compartments, even though regulatory you are compliant to do that, which I think is a flaw in the standard, and why really building integrated PV needs to have its own specific test standard than a generic roof covering, really.
Yeah, I think that's right. I think you want to be able to go a bit like in the regulations. If we were trying to install solar PV into BS 7671 and we were looking in there and there was just no guidance on solar, we were having to look at, right, how do we run cables in walls? That's all in there, protection for that circuit. But if there was no guidance on sizing your DC cables, or the type of protection level what your inverter should have in, or what you need to have in terms of RCD protection if they don't, and all this other stuff, if none of that guidance was there, you'd kind of just be guessing. And I think that's maybe sounding from what you've said, people are trying to kind of shoehorn the regulations we've got into fitting solar PV in roof where actually, like you say, maybe the next step for the regulations are to actually go, right, we need now a full section for this because every 1 in 10 new builds is getting that solar PV fitted. We need to make sure it's been done correctly before we have millions of these out there that are all non-compliant.
Yeah, absolutely. And I guess, is this just a concern within roof? I've read some stuff about on roof still, as we're rolling this out, say in terraced homes, where you can have your on roof system, but you're only maybe 600 to 800 mil apart from next doors. Is that enough to start transferring fire from one property to other down the street more than it otherwise would? And it doesn't necessarily have to be something that originated in the solar system. House fires are relatively common still, sadly. And is that something we need to be looking at as well, or is that fine as it is?
I think I'm working on different parts of different research for different organisations, such as BRE, the Fire Industry Association, and one of the research is looking at on roof whether there is minimum distances to the boundary. Basically, I have my concerns that this will impact the amount of modules you may get on a roof as well, and it may be counterintuitive, but there needs to be a line in the sand, I think, somewhere. And there is research that has been conducted on sort of the fire spread of different modules specifically. So obviously in America, the standards are absolutely ridiculous. They are really stringent on sort of the fire spread and, even the roof covering. Every particular layout, even on roof and in roof, has to be physically tested, whether that's on a slate roof, tiled roof, shingle roof in America particularly. Every combination has to be tested for that to be a compliant solution, where we don't do that over here. We just sort of do our 1 test, 2 tests for it fire-wise, and that's approved whatever the makeup of that roof material is. So I think research and the outcomes of this will be coming out probably middle to end of next year, hopefully, where there will be guidance on it. But it needs to have a sensible level approach, because ultimately, if we're moving towards net zero, if we start saying 2 meters from every boundary, then you've eaten up most of that person's roof, and it's not viable to have solar at that point.
100%. I think that's just a good point. It's trying to find that line of safety, isn't it, to value as well, I guess. And because terraced homes are generally quite narrow, we live in small little plots in the UK. And is this maybe a blasé approach to safety in the UK due to the way our buildings are constructed? It's brick, it's block, it's tile, whereas in America there's a lot of timber construction. Or is it because we're behind the curve in rollout and they've had solar for longer than us? Or is there no real rhyme or reason to it?
I think ultimately, like when you look at sort of international and you look at Australia and America, they've had it for a lot longer. So I think they've sort of had the teething issues, and they've kind of made changes to it a lot sooner. I find within the UK we're quite reactive as opposed to being proactive on these things, even though there's already been instances of these happening many times internationally and taking these standards. The only reason I really say that, apart from, is the PAS standard, where it's really been a proactive approach, but normally everything seems to be quite reactive. But yeah, I think because it's been around in the UK for quite a while now, but I find we're still behind the curve ultimately, really.
Yeah. I think I was just going to say, I think the PAS 6300 that came out, that has been the most proactive that the solar industry has been for forever. I don't think there's ever been anything that's been proactive like that. Obviously, it's had a backlash and everything, and some points are absolutely valid, and there's lots of points there to argue about. But I'm hoping that that's kind of a sign that things are being taken a little bit more seriously with this now, because it is becoming more common. And the point you raised about 2 meters from a boundary and stuff, like if stuff like that does come out, it does kill it a little bit. And I think no matter what you fit on your property, be it an extension, be it a new double oven, whatever you fit in, solar PV battery, you are increasing the risk of something happening in that house. You're adding more things, more electrical appliances or equipment in that property. You are increasing the risk of something happening. Now it's getting that balance between having the benefit of that product and mitigating the risk of it either causing a fire, helping the spread of a fire, or causing you to not be able to get out of that property. And I think you need to. That's why I think the PAS was quite good, because it said we're not going to say that every property can only have 3 kilowatts because of the risk of potentially having too much power in that house and causing an issue. It was more about have solar, have battery. These are the locations that we want you to put it, but also make sure the fire safety of that property is up to a standard which it should be really anyway. The smoke alarms are fairly cheap in comparison to some of this kit that you're fitting on a property. You might be fitting 30 grand's worth of equipment, and £1,000 of that is a brand new smoke alarm system. Like, it's next to nothing compared to the cost of the equipment. But yet that's what we get pushback most on, is that no one else is actually quoted for smoke alarms. Why do I need it? And you're like, mate, it's £1,000 compared to 30 grand you're spending, and that can be the difference for you getting your family out of that property. If there's a fire, forget about the solar and battery. If there's a fire, so for me, it's it was definitely the most proactive thing, and the risk/reward needs to be balanced. But yeah, I think certainly now when we're getting bigger panels in terms of output, you can fit a really meaningful system on a terrace property, and I think it would be a shame if that was reduced because of the potential risk of fire spreading left and right. Whereas it would be nice if those properties were all actually had smoke detection, so that yes, it doesn't stop the fire taking hold of that property, but at least no one's dying in that house.
Yeah, I think there's a few angles there. You know, we don't want to scare anyone that thinking that solar panels set on fire very often. I don't think they actually do. They're relatively safe in the way they work and what they do. But it's more the fires that happen more naturally within a dwelling, and trying to make sure we're not reducing the fire safety as a whole because of that. And you made a great point with the smoke alarms. 99 times in 100, maybe 999 times in 1,000, when they're going off, it'll be because there's something else on fire, not the PV or your battery. And having those put into homes through the rollout of renewables, if we're going to go on this net zero drive, is a huge opportunity, I think, to try and improve safety across every home in the country. 'Cause it's still staggering how many don't have working smoke alarms. So that's a problem we can solve through that process. And then I think rather than making it more horrendous on installers and consumers in where you can put these panels, we've got considerations around the wind and keeping away from the edges and stuff for things like that. But I think it's more looking at the manufacturers, and like you've said, Luke, there's a standard for this. You need to make your product to this standard and prove it to us. Standardise the MC4 connectors that are being used. Or have a connector that's standardised. If the MC4 connectors are failing so often, let's use a different one. Let's fix that issue. If there's a problem with panels that maybe do ignite more easily than others, have a standard in place that takes those out the market in the UK. And it's not on the playing field anymore for other installers to spec this stuff at a lower cost to a more diligent installer who's maybe done that research. So what people are paying for is going to give them long-term safety and also decent value in performance. And I've said this to a few people in industry of late. I think the last knock-ins have been able to put something in place now that ensures that is the case through the mass adoption phase, which still only had relatively small scale adoption in the UK. This is the chance to get it right, I think.
Yeah, I think it's mad though, Sam. Obviously, like you get questioned on, and probably you do, Mark, about that additional cost on the job for safety, because obviously your competition out there, and I do find the solar industry being in contracting myself is just on a race to the bottom, unfortunately, and that comes with poor quality, poor materials, poor workmanship, which is a result of these fires from occurring. And they are, they're not daily, they are quite a rare occurrence, but unfortunately when they do happen, they do have devastating effects to the building because of the location they're in. And when the fire brigade obviously attend and put massive amounts of water on it, then the whole house is flooded as well as a consequence. So the actual having that conversation with your client just is baffling, because it's just that is ultimate safety, and you're providing that by goodwill of your as a company who's conscious of what you're doing. But you've got obviously always that competition behind you who are sort of undercutting, trying to just do things for cheap, and and ultimately they win a fair share of that work as well, unfortunately.
Yeah, I would say that most of the people that we actually get on the phone with, once they've had our quote, because it's very rare that someone only gets one quote. It used to be more common because there was fewer people doing these sorts of installations. Since a lot of other contractors have come into the market, customers are able to easily get 5 quotes for every single job. You can get 3 to 5 quotes very quickly and very easily. And I'd say that a lot of, I'd probably say 4 out of the 5, if we've priced for 5, there's probably 4 out of the 5 have not had even a mention about smoke alarms in their proposals. And I think that's a tricky one for us. If we get on the phone to that customer and explain why we're doing it, provide them with the document, tell them what page it's on, some customers see that as a red flag with everybody else and go, wow, well, no one else has mentioned this. That's a real almost selling point for them to use us or you or whoever else is in that seat where they're actually recommending smoke alarms. But others say, okay, well, I'll go back to the other installers then and I'll get them to add in smoke alarms and they're still going to be cheaper. And for me, I kind of go, well, okay, you're quite within your rights to do that. Obviously, we've recommended that right at the start. So it's a bit of a red flag if they've not even mentioned it. I'm sure they'd be happy to fit you those, but why have they not recommended that right at the start? And I think that might not be because they're looking to be cheap and do a rubbish job. It might be an education piece where they've gone, I didn't even know about this PAS document.
Yeah.
Should be knowing about it. You know, with social media and everything out there, it's never been easier to get all this sort of information. But it's that mass kind of learning journey that the whole industry needs to be on so that everyone's kind of batting from an even playing field, really. Because we do lose jobs because of the smoke alarm cost. That phone call that was on just before you arrived, Luke, was basically trying to chat to a customer about the smoke alarm system and all of that, and none of the others had mentioned it. And it's trying to get them onto our side of that, because ultimately a lot of this stuff does come down to cost. You can be the best installer in the world. I'm not saying I am, but I'm saying you can be really good at your craft, but still lose 3 out of 5 jobs because you're outside of people's budget. So I think if everyone's batting it around that budget, then there isn't that really cheap option.
Yeah, it can soon unravel if you can set that discussion out with the customer, because you fall into the realms of, are they specifying BirdGuard optimizers, all these other things that people will cut away. And the amount of discussions I've had with customers who say their installers have told them they don't need optimizers because there's no shading. So what about the safety function? Have they spec'd in DC rapid shutdown into the system? Have any of these things been discussed with you? And sometimes you can go on those journeys with people and they'll be receptive to that and understand. And other people are just looking at how fast someone's told them they'll get their money back and what the headline cost is. And that's as far as it goes. And that's why I'm saying we're looking at the kind of the industry of things to help us with that. We can't have that exact argument as installers, Sam. We just can't at that scale. We're going to be drowned out by the noise of these bigger companies doing it for those headline prices. But if the industry of things starts to say, actually, you need BirdGuard in every system to stop damage to your panels and potential fire and hotspots, you need optimizers that are maybe going to be monitoring for temperature or any arcs and sparks that are in your system, forgetting the issues with the extra MC4 connectors for a minute. And then maybe even some of the inverters that are used that are more technologically advanced than others, and they can monitor for earth voltages, arcs, earth leakages, DC voltages appearing in places they shouldn't, and shut down before something becomes a problem. So instead of a fire investigation, you've got a customer ringing you up because the PV isn't working. That's a much better place to be than when the worst's happened. But I think it needs the industry of things to help solve that. I don't know what you think.
I think it's frustrating that it's like the whole DC isolator argument. We're all singing from the same hymn sheet as an industry, yet there's conflicting information across the board, and it's so frustrating because we should be collectively saying, right, these are the standards, this is what we're doing, not individual bodies going off and I'd say yes, install DC isolators, for example, and others saying no, and it's just confusing and muddying the waters when really is an industry. And for best practice, we all need clarity to be sort of singing off that same hymn sheet ultimately.
Yeah, where do you fall on the DC isolator side then? You brought it up, I didn't bring it up.
This is an ongoing discussion. I know Mark's quite strong on this as well, but I'm in the agreement with Mark, really. I think DC isolators should be installed separately. Again, I think a big part of this is around the training and education around the correct selection and erection of DC isolators, including like termination, etc. But I think relying solely on integrated isolators within inverters without a lock-off function, etc., I don't see as fit for purpose in my professional opinion.
Yeah, no, we all are in agreement on that, and I think there's obviously a risk. Again, you've installed another isolation point that's got its function is to physically forcibly disconnect that DC arc, which is going to generate temperature, and there is a risk there. But the risk of working on some live PV cables at 500 to 1,000 volts potentially seems to me to be madness if you haven't got some sort of module level shutdown where you can work at safe touch voltages. So for me, it just seems like a strange argument to have to reduce the amount of lock-off points and safe isolation points just because potentially they could cause a fire, which they could do. You know, the inverter could cause a fire, the AC isolator could cause a fire, the generation meter that serves no purpose now could cause a fire. So, you know, all these sorts of points, I think the discussion needs to be had, but I feel like we need to just reach consensus on it now and just go, look, let's not be silly. Let's just fit these now.
I think it came from a good place that the analysis of the data was showing MC4s and DC isolators are the biggest points of failure and fire within a PV system. So the argument of let's reduce them to the lowest possible denominator is a good one, but it shouldn't be to the point of affecting safety. And that can be window cleaners wanting to clean solar panels, and we're looking at capacitive coupling and giving them a point. You know, they might be in there and think, well, they might be knowledgeable, I'll turn the AC and DC isolators off, but the customers come back from work while they're out there cleaning them and put them back on, and they've got a shock while they're doing what they're doing on the steps and ended up on the garden pavers. You know, there's that kind of angle to it beyond just electrical safety. So I think the function they serve is important. And you're dead right, Luke. It's trying to get some consensus because there are so many parties in this discussion. We've got hours of the electrical industry that we're all familiar with, but there's also the building regs. There's some of these standards that are international, beyond access to electricians as well. That's the other thing. Getting access to these standards is expensive and not so easy. There's international reports, and it's, again, like I said at the start, is where do we draw the line of our responsibility and what we do need to know and understand as installers? I think we are relying on the industry of things, maybe the wholesale network as well, to provide us with some of this information, for them to say, actually, to when you're ordering your kits, you know, you've ordered this particular component to go in a roof with that. That's not actually something that's approved. Were you aware of that? Or we've noticed you're not ordering any smoke alarms. You're getting them from somewhere else. Maybe that's asking too much, but, you know, it's one of those, I think, where there's a lot coming down onto installers and responsibility at our door, and I take it seriously, but I think it is a bit unfairly weighted, if I'm being honest. And maybe using people like yourself, Luke, as consultants can take some of that heavy lifting away. I know if I was taking on a big project, I would be asking someone like you for that support and confidence in knowing we've designed this right. We've had separate witness testing, so we can be as confident as we can be that it's been done right.
I think, obviously, just in that little conversation piece there, Matt, you must have named 3 or 4 different areas where people can get their information from. And that just shows that there are so many people that are contributing to this, but we need to have somewhere that is the authority that is fed into, whether that's MCS, into their guidance, or whether or not that's, you know, on the IT side. Like, we can't have everybody, can have everyone contributing to the conversation, but we can't have everybody kind of being the voice of what you should do. The wholesaler can't be the one saying, well, we sell all these, you need this product with this, and that's the way you do it. If there's nothing there to back it up, just because that's how they sell a lot of their kits. You need somewhere to go back and go, again, like we said right at the head of this podcast, you need to get right back to the main rules of this and go, right, what are the actual rules, and where do I go to find those, just to check that this is right? Because you're never going to stop wholesalers selling a kit, because that is a really easy way for people to get their equipment. But you need to be able to kind of go back to ground zero and go, right, well, what are the rules? What do I need to be as a competent and informed installer? What do I need to consider when it comes to fire safety, and a lot more about solar PV? And I think that's kind of where we're a little bit muddy at the minute. We're not too sure where to.
Credit to you, Luke, because you popped that onto LinkedIn. I've seen you going on for months about these fires that are happening both in and on roof, and even around EV and battery storage, and a consistent voice racing these discussions. And I think in large part, MCS's recent thing that they put out around in roof solar was maybe in response to some of the stuff you have been doing. So, you know, massive credit to you, but it shouldn't need to come through social media. I don't think that's you know.
Yeah, no, agreed. And I think a lot of this as well, like obviously the data that's out there is dated now. It's like, I think the BRE report specifically saying DC isolators were 44% off the top of my head out of 80 incidences was from 2017. So that was a long time ago now. You know, I think there is research going to be worked on specifically to bring them numbers up to present. But as these things take a little while, they probably won't be out until late next year, even 2026. But I think we need to be following that data curve and, you know, obtaining all these instances and finding out like what is going on now. Because obviously you look at the MTS dashboard and, you know, solar PV across the country is increasing. But what about the numbers around these fires? I think really the ultimate people who I'm seeing driving this and standards are the insurance companies who are saying no, we want this, or they're specifying rapid shutdown or roof level sort of DC isolation and that, not the IET or MCS or any of the sort of them guys who are dictating it. It's more the insurance sector who are saying no, we're doing it because we're insuring that building and we want to minimize our losses ultimately.
Yeah, that is exactly what we're seeing, and you do get driven by that because if you've got, I'm thinking of another one where this company supply lots of like AV equipment for a lot of big concerts and do like the Barbican in York for these big stars that come to our little little city in York, but around the world and around the country, and they have to have a fire risk assessment done because they've got millions of pounds worth of equipment in this massive shed, basically, and it's got solar PV on it. And they've had the same insurer for many years. And then one year they came around and an assessment went, you need rapid shutdown on your solar PV. And they're like, what? We've had this on for 5 years or 10 years, and you've never once mentioned it. Yeah, with the insurance company now saying you need this on. So we had to go back and fit a rapid shutdown device to isolate. It was only about, from the isolation point to the inverter, it was only about 5 meters of cable. so he was fuming that he had to do it. But to me, that kind of was a line in the sand, or certainly an arrow in the trajectory of where this is going. And it's only going to take a few more of like the Peterborough Fire and these other insurance companies to get stung for them to go rapid shutdown on every single solar PV system that is under our insurance. And as soon as one of them's done it, that opens the gate for a lot of them to do it.
And you've seen a lot more of them now. They're publishing their own guidance around it. So, for the insurers to take quite a big interest in PV and renewables as a whole, they're obviously seeing claims increase. That's why they're clamping down on it and wanting to educate homeowners or business owners and even installers to say, if you're dealing with us, these are our requirements. So, they're obviously seeing a rise in these instances, hence why they're sort of putting their own standards in place.
Yeah, I mean, the statistical analysis is what forms their rates they charge, isn't it? We said about the fire service having good stats. Insurance companies, they have stats on stats, and that's what they set everything against. And ultimately, they might start driving that into the domestic space. And that's the risk for industry. And I'm worried for industry about this in terms of the value of our regulations. If insurers are dictating things that are beyond what that is setting, and if manufacturers are coming up with technologies that aren't covered in those regulations and we're constantly deviating from them to satisfy other parts, where is the value in those regulations? They need to get way better at getting those updated. I think we've had that historical thing where we can be 5 to 10 years behind the curve in normal electrical worlds because it's quite consistent. But with renewables and EV, and we're looking at vehicle to grid now, and you go back to your home and all the rest of it, that's so fast. And they're so far behind that curve. There's other things that are making us as installers have to change our ways that don't actually comply with the regs that are in place. It's a really difficult one. I think, I don't know what the solution is, but it is a problem for us as installers. The deviations box on one of our certificates can become quite full. You've got to state those things that don't comply with the regs. EV Ultra is a good example, and PV Ultra, SWAs we've been discussing of late, those kind of things, which I think bring improvements. And it's the same with optimizers and relying on those in terms of isolation points that are using microelectronics rather than a physical switch, and how they can help. And maybe insurers are going to start saying, we want micro optimizers on these systems that are monitoring temperatures at a panel by panel level, arcs at a panel by panel level, and can provide the rapid shutdown function. And I'm speculating, but you can see it happening, can't you?
Yeah, I mean, in terms of because you're kind of in this kind of area, Luke, what do you think is coming down the track for sort of, if we start on commercial really, because that tends to be where insurers are really keen on, and it kind of leads on from your point, but what could potentially come down into the domestic level? Are you kind of seeing any tightening up of things like rapid shutdown or fire alarm integration, or kind of them stating an MC4 that has to be used? Is there anything like that?
I think optimizers, I think even if you look at the US market, they've been using rapid shutdown since 2014 as a requirement in their sort of electrical code, our equivalent BS 7671. So optimizers, fire alarm integration as a minimum, really. But yeah, commercial, it's a minefield. It's every different insurance sectors now, and companies are saying every 30 meters there needs to be a meter and a half gap to stop propagation in the event of that sort of area of PV catching fire. It's a minefield, to be honest, and obviously depending on what the building is, like you said, obviously like an AV building, it's a high risk, high loss potentially. I've done some work with like sort of chemical storage buildings and things like that, where they're sort of saying, "Ooh, I don't think we want to kind of stay away from renewables really, ultimately, because of what the building's containing and what the operation they're running as well." So it's quite a wide range, and every insurer is different. I'm finding there's no set sort of, they're not singing all off the same hymn sheet. Some of the underwriters are more knowledgeable. Some of them are just sort of blanketing, fit rapid shutdown, maybe not knowing what the consequences or the improvement that may have, really. I think it's a bit of an educating game for them as well, to sort of pick up within industry and in the sector, really, to sort of find out what works. But as Mark said, that they've got the numbers between, they know how they price their premiums basically on these sort of instances. But the frustrating thing is they don't share the data to industry and sector. They keep very stum on it, so we don't get to learn from these sort of instances or what they're seeing in the field either.
Because there's ambiguity even within one of those little solutions. The rapid shutdown. Is that module level rapid shutdown where it's locking it underneath the panel or set of 2 panels, or is it just string shutdown on entering the building? Because again, there's different levels that for me, I think module level shutdown seems to be common sense, because you've not got that potential on the input side of that rapid shutdown device that's locked that string out, where it could be arcing away, up on the roof between some connections. And yes, the inverter's been shut down, but have we got a dead short between that panel or that group of panels because of something that's happened? Whereas module level shutdown, we are locking that module down from each other. Still not completely bulletproof, but for me, if we can drop that string voltage down to 1 volt or a couple of volts per panel, then that just makes the case for the actual potential there is so much lower than if we've still got 800 volts coming into a device. I think anything is an improvement, but I think we do need to be guided by someone in the industry, be like insurance companies. And I think it's going to be a bit of a bun fight for a few years until people actually get their heads together and go, right, we need to actually nail this now, because we've got people half complying to standards that they thought they were fully compliant to, which is just, it's neither here nor there. You kind of done what you think's right, but it's not actually fully right.
I think it's trying to blend what are the regulatory requirements with your 60947-1 and 3 isolators into the rapid shutdown function. When you're relying on an optimizer, you're not really getting that from my understanding, but getting as close to the source and point of generation as you can makes a lot of sense in your shutdown procedure, especially when you can't turn the sunlight off. I know they're coming up with treatments that fire services can spray onto these panels now to try and cover them over, but let's be honest, that's not going to be in every fleet of fire responders, is it? It's just not. So having it where you can turn it off at panel by panel level, or even the self-monitoring, self-testing, so it doesn't ever get to that stage where the fire service are responding. You've just got a panel and an optimizer that's gone into a fault state, stopped that fire, seen that burning MC4 connector, and it's more maintenance rather than catastrophic consequence. So there's a place for that, but it does need to come from the data, and the industry of things needs to get on that curve, I think, and accept some of these technologies. We see the same with pen faults and electronic RCDs and all of the conversations around that. And I don't blame the regulators at all. They've got to follow the processes that they've got in place, have those discussions, make sure it's all committee-led. But maybe there's a space somewhere for somebody to do something more quickly, like the IET. We saw the IET 01 around the pen fault devices, for example. Maybe there's something that can happen there. But again, it's all those voices talking at us again from different places, isn't it?
Yeah.
So this is another long chat with Luke that we've really enjoyed, and we're breaking it apart into 2 episodes because nobody wants to sit and listen to a 2-hour podcast all at once. So we're going to come back next week where we get into more of the fire safety side of things in terms of battery storage, EVs, and also some of the things that are going on at an industry and committee level around all of that. and ways that you can be involved in the discussion. So it's one to check back to and don't miss out on. Massive thanks to Luke for spending the time he did in chatting with us, and as always to my co-host Sam. If you've enjoyed this, please don't forget to share it out onto your social media. We're trying to reach as many people as possible, and that involves the help of the audience watching and listening along. Don't forget to give us a thumbs up and subscribe to the channel as well, and we'll see you next week to finish up this conversation with Luke.